Enhanced IGRP or EIGRP, it is a Cisco-owned hybrid routing protocol that is designed to route traffic within the autonomous system. It's a hybrid protocol, which means it combines the features from both link state and distance vector protocols. As a distance vector, it sends out an update that contains all the routing information from the perspective of the advertising router. And as a link state, it synchronizes the routing table between the neighbors at the startup and sends out only the partial update when the topology gets changed. On the surface, it has a similar working mechanism as the OSPF protocol. First step is to become the neighbors. A neighbor first sends a hello packet and another neighbor checks the requirement and responds back with a hello if everything is fine to become the neighbors. A periodic hello packet is sent back and forth to ensure the connection is alive. Second step is to exchange the network information. After becoming neighbors, routers share their entire network information using an update packet, followed by an acknowledgement. And when the link is changed, only the partial updates are shared between the routers. And for the third one, it has to find the best route. And to find the route, all EIGRP routers have these tables: neighbor table, topology table, and the routing table. A neighbor table keeps track of all the adjacent routers with their IP address and the port they are connected to. A topology table keeps track of all the networks that were advertised by the neighbors, along with the route to reach those networks. This value is called a metric or cost, and EIGRP uses a diffusing update algorithm to calculate the metric for each route. And the path with the lowest metric is chosen as the successor, the best route, and is placed in the routing table. And the second best route is called a feasible successor, which is a backup route in case the successor route fails. For example, in this network, to reach from router A to router C, the successor route is through A, D, and C, and the feasible successor route is through A, B, E, and C. The metric to select the best route is calculated using a formula, and there are multiple formulas in case other network factors have to be taken into consideration as well. And finally, in a scenario where the network connection drops, the link goes from passive mode, which is working mode, to the active mode, which means it is actively found. And the router sends a query packet to its neighbor regarding the alternative routes. If the route is available, the router replies. However, if there is no route available, it is considered a dead network, and the network is removed from the routing table. So to summarize, EIGRP quickly adapted network changes by using a backup link and sending only the necessary update, making it fast, scalable, and reliable routing protocol. This is all for EIGRP. I'll see you in the next session. Meanwhile, subscribe,